Welcome to Miss Gooch's first attempt at a screencast lesson. So, like it says, you're going to need your sound on, but I guess that's sort of redundant because you're already listening to me. I'm away today at a cross-country meeting, so here we go with our lesson. If you have questions or any things you need clarifying, just comment in the Google Classroom on the post where this video is, and I'll get back to you today, okay? So here we go. Take out a piece of paper and a pen because first part of the lesson I need you to write or copy down while I teach you. So before we get started with the problem solving, I need to talk to you about the difference between distance and displacement. There is a very distinguished difference between these two physical quantities, so that's why we need to discuss that before we get started on examples. In order to illustrate the difference between distance and displacement, I'm going to use an example. So, along this line, connecting these dots or whatever, there lies Annie. Annie's gonna go from A to B and then to C as her journey, but we'll start her at A for now. What we need is to distinguish how far things are apart. So we'll say that this is about 3 kilometers, and the distance between A and B is going to be 5 kilometers. And then we have our legend, of course, north, east, south, west. Okay, so in order to distinguish the difference between distance and displacement, I'll give you an example. So here's Annie traveling. She goes from A to B to C. How far has she gone? So you probably said 8 kilometers. That's right. That's the measure of her distance. So to see the difference between distance and displacement, I'm going to move Annie again. She's going to follow the same pattern. Oh, I took some of the K with that one. Oh well. We're going to talk about her displacement now. So the displacement is defined as the change in position of an object overall. So if she goes from A to B to C, her total change in position has only been 3 kilometers according to where she started from. So displacement's special because it only cares about the starting position and the ending position, and it's a vector quantity, meaning it has direction. Distance, you notice there's no direction required. So yeah, when we distinguish the two between each other with letters or symbols, distance is often written as just D total, and then displacement is called delta D, and it has an arrow on top. The arrow indicates a vector quantity. So whenever you write out displacement or velocity or acceleration and you indicate that it's a vector, you have to include this direction as well as the magnitude or size of the displacement. Another important distinguishment from in physics is speed versus velocity. Speed is defined as an object's total distance over the time in which it takes to travel that distance. So our equation looks like this. Okay, and it's pretty straightforward. This is not a vector, okay, so it does not require direction. Velocity, however, uses the idea of displacement over change in time. So velocity being a vector, symbol is going to be v, average, uses the change in position, this guy here, over the total time, just as this one used the total time as well. Okay, so when calculating velocity or speed, you have to consider, what was given in the question. Was it the distance or was it the displacement, right? Because that's different. We just saw the difference between those two things. Typically, from now on, we're going to be dealing with this quantity here, the displacement and the velocity, in our problem solving. So now we're going to go to the two examples from the note we had yesterday. So I'll give you a second to get that out, and then we're going to go through those examples.